Greetings everyone. Let me show you how to set up your first Windows EC2 instance in AWS. But before you do that, let's make sure we're in the right region. So if you plan on setting up an EC2 instance, make sure you choose the region you want it installed in. I'm going to go with Canada Central right now. Pick whichever one you need in order to accomplish your goal. If you pick the wrong one, you're going to have to recreate that instance in the region you want it in later on. So let's get it right to begin with. Region first, I'm choosing Canada Central. Under Services, I'm going to pick EC2. Once I'm in the EC2 Management Console, I'm going to click on Instances on the far side. And then I'm going to click on Launch Instances at the top. So our first step is to choose our AMI. It is our template that identifies the operating system that's going to be installed, any applications that need to be installed, any services that need to be installed. And in this case, since we're going with Windows, under our Quick Start menu, we have many different Windows options available to us. Windows 2016, we have 2012, and then there's also some different flavors as here. We can have some editions, standard edition, data center editions. Some of these will already be packaged, for example, with the container services. Some of them will be packaged with SQL Server. So depending on what your goal is, that will determine which flavor of AMI you want to choose for your Windows installation. If you are looking for AMIs that you've already created, because you can create your own AMIs, you'd have them here under My AMIs, which I don't have any right now in Canada Central. If you are looking for something specific on the AWS Marketplace, you can find that over here. And then also there are community AMIs. So AMIs that AWS may have packaged together, or even other members of the AWS community that created an AMI with certain software and configurations already on it that you can go ahead and utilize. But under the Quick Start today, I'm just going to show you how to set up our Microsoft Windows Server 2016 Base Edition. Click on Select. Next, we choose our instance type in step 2. Instance type is referring to the amount of CPU power we need, the amount of RAM, the type of storage we want, how we want the network to perform, whether IPv6 is supported or not. And we have different families we can choose from. General purpose family and compute optimized families and memory optimized families and storage optimized families. So all of these different families are going to give us micro, small, medium, large, extra large, 2 extra large flavors. And all this is referring to is the number of CPUs, the amount of memory, the type of storage, and the type of network performance we can expect out of that particular instance type. If you go down here, you'll see 96 virtual CPUs with 368 gigs of RAM. Whew, it's quite a hefty server we have there. But for today's demonstration, I'm going to go with T2 Micro, which is 1 virtual CPU and 1 gig of RAM. It's going to use EBS storage, which is, in this case, not an EBS optimized storage. It's just EBS storage. And then we have low to moderate network performance, and it does support IPv6. I will then click on Configure Instance Details in the bottom corner. Now, this is where we specify some of the various details pertaining to this specific server we're setting up. So I could set up one server, or I could set up multiple servers at the same time. I'm just going to go ahead with one. Typically, if you're going to set up multiple servers at the same time, you're going to go with an auto-scaling group instead of going through this process right here. Network. We need to choose a virtual network to put our EC2 instance in. Right now, I don't have any set up, but there is the default virtual network you can put your servers in. So if this is your first EC2 instance and you haven't set up custom VPCs, that's okay. You can put your server in this default VPC, which comes already inside of your account. So the default VPC I'm going to go with for the virtual network, and then inside of that VPC, we have different subnets. In this case, there are 2 available in Canada Central, If you're in a different region, there might be 4 or 3 or 5 or 6, really depending on the region you're in. Canada Central only has 2, which means that we have one subnet for availability zone A and one subnet for availability zone B. So AWS is asking me right now, when you deploy this server, do you want it in availability zone 1A subnet that exists right now, or the 1B subnet that exists? Or if we had custom VPC set up, then my custom subnets would be showing up here, once I chose my custom VPC, of course. Or, in this case, since we chose the default VPC, we can also choose no preference in this particular example. And essentially I'm saying, AWS, you go ahead and choose where you want to put my server. Either put it in the subnet in 1A or the subnet in 1B. Doesn't matter to me. It's up to you where you want to put it. Why do they give you this option? So that way their AWS can balance out resource utilization in the back end. So if they have overutilization right now in availability zone 1A, they're going to throw you in 1B. That way they can start to balance out their clients a little bit better. So I'm just going to pick 1A here because that's what I feel like doing. Auto assign public IP address. So in this example here, we can use the subnet setting and it says it's enabled. What that means is that the subnet has been set up to hand out IP addresses to the servers. If it said disabled, it means that the subnet has not been set up for that. So then you can control it with either enable or disable down here. So if I click on enabled, it's the same thing as using the subnet setting right now because the subnet setting says enable. If the subnet setting said disabled, then if I choose enable, it tells AWS, make sure you give this server a public IP address. So if you want a public IP address on your server, make sure that you have enabled selected here either through the use the subnet setting or enabled. If you don't want a public IP address assigned to it automatically, then just click on disabled. So I'm going to go with use subnet setting enabled at this point in time. If you want to join a directory domain, you can do so here. If you want to set up or associate the server with an IAM role, you can do that here as well. You can control the shutdown behavior, meaning that if somebody is in the Windows operating system and they click on shutdown, what's going to happen? Is it just going to stop the server? Or is it going to terminate the server, meaning that the server will completely be removed from my account, meaning that it will no longer exist at all. So we can control what happens. So if somebody logs into the server, click shutdown, but we want it to completely terminate the server, then we can do that just by selecting terminate here. But if we want it to just stop the server so that way there we can restart it later on, then we want to put stop here. Protection against accidental termination. Nice little feature which ensures that if somebody wants to terminate a server, they are going to have to perform 2 steps instead of 1 step. So if this is unchecked, what that means is that anybody can go to my server, click on its properties, and say terminate. This is in the AWS Management Console. They can terminate it. They can get rid of it. To protect against accidental termination means that they would have to disable this feature. So if this was checked, they would have to disable this feature first and then terminate the instance if they wanted to get rid of it. So it's no longer accidental because they would have to shut off the feature first and then terminate it. That's typically not going to happen by accident at that point in time. So I'm just going to leave that off right now. It's up to you whether you need that or not. You have basic monitoring by default with CloudWatch, but if you want detailed monitoring, you click on this checkbox. Additional charges will apply. Tenancy. Shared is fine right now for me because I really don't care if this is on a server or in a rack that is being used by many different AWS customers. But if that is a problem, we can go with dedicated hardware, dedicated tenancy if we need to. But most of us can get away with shared in testing environments as well as production environments. We get 1 network interface card by default, Ethernet 0. It's a virtual network interface card. We can add additional network interface cards if we need to, just by clicking on Add Device. And then under Advanced Details, we can put in user data. So user data is going to accept scripts. So for example, here, this is a Windows 2016 server we're setting up. We're going to put PowerShell scripting in here if we need to. So if I don't put anything in here, my server is going to be installed and set up using all the Windows defaults. However, what I can do is I could put scripts in here, PowerShell scripts, that once the server is up and running, these scripts are automatically going to run even before I log in for the very first time, and the server will then be configured with whatever I had put in these PowerShell scripts. So if you want IIS installed as an example, then you can put the PowerShell scripts in here that will install IIS for you. If you want to run Windows Update right away, then you can put the script in here that will run Windows Update for you right away. If you need to join a domain or whatever you need to do that you can accomplish with PowerShell, you can put the script in here and it will run for you. So that way there, when you log into the server for the first time, everything that was here in the PowerShell script will have been completed for you. I'm going to leave it blank for right now. Let's go ahead and click Add Storage. Now, by default, I have a root volume. This is where the operating system is going to be installed. It is 30 gigs in size, and that is the minimum size you can have for a root volume for Windows 2016 on AWS. Volume type, there's 3 options to choose from here in Canada Central, but for root volumes, your best option is the general purpose SSD drive. You don't need provisioned IOPS here. You don't need magnetic here. This is the best option, so we're going to go with it. But if we needed to add another volume and we wanted to use a different hard drive type for that, we can definitely use a different hard drive type for that if we want to. Also, delete on termination is an option here. Delete on termination is set by default on the root volume, but if I simply uncheck that, what that means is if the EC2 server gets terminated, the volume will now be preserved, meaning this volume with the configuration of the operating system and the services and everything we've done to that server will be preserved. You see, EBS volumes are separate from the host. So I have my server, which is on a physical device with CPU and memory and even hard drives. An EBS volume is not a hard drive on that host. It's not. An EBS volume is a hard drive in a storage area network, a SAN. So we have a separation here between the drive and the actual host. So if the host fails, the host gets destroyed, the host gets damaged, a truck drives over the host, well, the EBS volume's still fine. It's somewhere else in the same availability zone. So this is hugely beneficial for us because I can preserve everything on my hard drive regardless of the state of the host. Now, we can use the hard drives that are on the host. They're called ephemeral drives, ephemeral storage, or instant store. They have 2 different names. Those would automatically get terminated, deleted. You can't do anything about that. But with EBS, you can control that. So if I uncheck the box, it means it will be preserved if the server gets terminated. If I check the box, it means it will be deleted if the server gets terminated. Also, you'll see here the root volume's not encrypted. But if we want to have other volumes on the server that are encrypted, we can go ahead and choose how we want to encrypt those volumes. Right, if I want to remove a volume here, I just click the X and that one's gone. All right, let's go to tags now. Now, tags is something that a lot of people skip. A lot of people don't see value in tags, but there's huge value in tags. Let me give you an example of a tag. So I type in a key, which is, in this case, I'm going to call it name, the key. And then I type in a value. Key value pair. Key value pair. That's all it is. For what? To provide descriptions, information, identity to this particular server. Now, why is this beneficial? Well, it allows me to identify number one, but what if later on down the road I want to run reports? I want to come up with reports for performance, and I want to be able to run that report on every server that belongs to a certain department. Oh, well, if I have a tag called department, and in this case, department is hosting, well, then that means I can run a report on all servers with the tag of department hosting. So that's very, very valuable. Very, very valuable. What about billing? What about billing? So for hosting, we might have multiple customers. So what if we had customer, and this customer was XYZ? Well, in that case, what if we want to run a report, a billing report, for every server that is used by customer XYZ? Well, now I can do that. So without tags, you cannot take advantage of all the additional services and features and resources that AWS gives you to make your life simpler. From a billing standpoint, a pricing standpoint, a tracking standpoint. So tags may not seem important at first when you're getting started with AWS, but as an advanced AWS administrator down the road, these are more important than you could ever imagine. So at some point in time, you're going to have to embrace tags, because all AWS resources can be tagged. And you're going to want to come up with a tagging strategy that benefits you. All right, so enough on tags right now. They'll be more important to you later on in your future. Let's configure a security group. So what is a security group? A security group controls the data that is allowed to flow into the server and the data that's allowed to flow out of the server. So data cannot flow in or out of the server unless it belongs to a security group. So every single EC2 instance has to have a security group associated with it. So right now, I am simply going to configure this server with a security group for administrative access. I'm not going to worry about anything else for this server right now. So what I'm going to do is I'm going to create a new security group, and we're going to call it our Windows Server group. And it's going to give me access to my Win server. All right, so that's a pretty basic security group. Now, how do we access our Windows servers? We use RDP, port number 3389. We can see that already listed here. And it says from everybody in the entire world that's on the internet. This is what I'm going to use here right now, but it's giving me a warning. Don't do that. That's not the right thing to do. Although it can be done, it's not smart, Raymond. Why? It's a security vulnerability. I'm giving everybody in the entire world the ability to RDP into my server. If that's okay, great. If not, we got to fix this. So how would we fix this? Well, here's some recommendations. If you're going to be accessing this server from work, well, what are the public IP addresses that your internal users get translated to when they go out on the internet? So network address translation. So whatever those public IP addresses are for network address translation, that's really the range of addresses you want to put in here. Only allow connections from that range of addresses. Let's say you're at home right now and you're just practicing and messing around. Well, what is the public IP address of your router that you get translated to when you go out on the internet? Put that address in there. That'll help you control who can access the server from a management standpoint. Now, this server, if it's a web server, we're going to add entries for web access. If it's an FTP server, we'd have to provide entries for FTP. So whatever the server's roles and responsibilities are, we'd also have to make sure that we open up the ports that allow connectivity. So you can think of a security group like a firewall. Deny by default in this case, and then you're only allowed to communicate in or out of the server if our security group says you're allowed to do so. So right now, I'm just going to set up RDP on this. I'm not going to worry about anything else. But for your environment, you'll have to customize a security group to meet your needs. Next, we click on Review and Launch. Everything we've just pretty much set up is listed right here. Next, I click on Launch, and then I get a pop-up. We need what is known as a key pair. So a key pair is a public and private key that go together. And in this case, it is for authentication purposes. So how do we use the public-private key pair? Well, for Linux and Windows servers, it's different in the world of AWS. To find out about Linux, check out my Linux videos. Today, we're going to focus strictly on Windows. So I need a key pair, a public-private key for authentication. So I'm going to go ahead and create a new key pair, and this one is going to be my Windows key pair, Windows KP. And then it says download the key pair. What I need is my the private key of the public-private key pair. So when I create this, it's going to download the private key to my local machine, and then we're going to have the public key stored on that particular server. So then a combination of this public and private key are going to give me the information I need to log into the server. So download the key pair now. Click on Save As. It saves it as a PEM file. So Windows KP PEM file. Click Save. And it's now stored locally on my computer. Next, I'm going to click Launch Instance. So Windows takes a little bit of time to get running. If you were setting up a Linux server, you could pretty much log in within, depending on the type, the size, the instance type of the server, but anywhere from 30 seconds to, let's say, a minute and a half, you'd be logged into the server. This one might take us a little longer. But let's talk about now how we can connect to this server, so that way there, when it's available to connect to, we can just go ahead and connect. So what we're going to need is we're going to need the host name of the server. And you can see the host name is already ready. It's right there. So what I'm going to do is I'm going to open up a notepad file right now. That's right, handy dandy notepad. And we're just going to copy the information we need to the notepad file. So there's my notepad file. I'm just going to bring it down to my other monitor. And I'm just going to copy and paste that in my notepad file, just so I have it available to me. All right, I missed the E there. I'm just going to add it in manually. All right, we're good. So the server's running now. What do I need? I need to know the username and password to log into the server because we use RDP to connect. So I'm going to need to put in the host name here. So let's copy and paste that host name into RDP. There we go. Click connect. And once this server is ready for connections, then I'll be able to connect. But right now, and it's ready. All right, perfect. So I need the username and password. Where do we get those? We get those by clicking on connect up here. So if I click on connect, it tells me there's the host name. Well, we already got that. There's the username. All right, so now we have the username. All right, let's put that right in there. And what do we need next? Now we need the password. So how do I get the password? You click on get password. Password's not available yet. So we have to wait for this password to be available. So although I have the other information, I still need to wait for that password. Now the password, there we go. The password comes from what? The PEM file. So what I need to do is I need to take that PEM file we downloaded and put it in here. If you don't have that PEM file, you're out of luck. You're not going to be able to connect. So I need the PEM file. Windows KP PEM. Put it in here. Decrypt password. And there it is. There is the password for everybody to see. That's right. Every single one of you get to see my password right now. Now, let's go ahead and bring in the credentials box. Put in password. And click OK. And we'll successfully log into this particular Windows 2016 server. Now, once you're logged into that server, you're going to want to make adjustments to what? Well, who can authenticate to that particular server? Are you going to keep using this administrator username and this password? Of course not. You're going to create your own user accounts on that server, or you're going to join it to an Active Directory domain if you didn't do it during the initial installation through PowerShell scripting in the user data. So those are options as well. We could have scripted everything. We could have scripted everything in the user data to create a new user account, to create a new password for us, to do a whole bunch of things. We could have done that, scripting. But without getting into the PowerShell scripting, we have a server up and running, and it gives us a username and password to log into it first and foremost. So back to the server. Here it is. And you can interact with it like a regular Windows 2016 server now that is sitting right beside you, maybe on your desk, probably not, but in your data center, more than likely. But it's available to you. And it's a fully functioning Windows 2016 server. So folks, have some fun. Log into your AWS account. Set up some Windows 2016 EC2 instances. Start playing around with it. So folks, until next time, enjoy. And we'll see you around.